So, welcome everyone. This is the 16th edition of Global Platform Tech Talk. Just a quick reminder of what a Tech Talk is. We'll have a 45-minute session. It will begin with a 30-minute presentation of the topic, followed by a 15-minute open discussion and Q&A. So, please note questions will be raised towards the end of the session. And for today's session, we will be diving into the topic of secure open silicon. I am pleased to introduce to you our speaker, um, Dominic Rizzo from ZeroRISC, and he is currently the new chair of the new task force, the Trusted Open Source Silicon Task Force. Dominic Rizzo is the founder and CEO of ZeroRISC. It's a startup focused on creating more transparent and trustworthy supply chain atop open silicon. Has been a long advocate of transparency and commercial relevance of open source projects, and especially he founded the OpenTitan project. So without further ado, I am giving you the floor, Dom, for your secure open source silicon presentation.
Great. Thanks so much, Mac. And let me, I don't often use Zoom, but I believe I should be able to. Please tell me if this works or not.
Perfect. Yes, we're
Great.
able to see
Well,
your screen.
fantastic. Thanks so much. I really appreciate the invitation to be here. Very happy to give this talk. I've really enjoyed working with Global Platform so far. Um, and really looking forward to the Q&A at the end. So first, I'm going to give a primer on open source and specifically how open source applies to secure and transparent, trustworthy silicon. I know that it might be, there's some new sort of potentially unfamiliar kind of terms, styles of working in open source. So I'm going to cover a little bit of that at the beginning and then dive more into, I think, kind of what most folks are here for. So, um, I'm as mentioned, founder and CEO of ZeroRISC, a company that's really focused on driving both adoption of open source silicon, secure silicon everywhere as a way to really up level supply chain integrity for the entire silicon ecosystem, and then providing the integrity management devices and services that kind of layer on top of that. In a past life, I founded the OpenTitan project, which is now a commercially proven open source implementation. Really happy to have started and led that effort, see it through to its first successful silicon tape out, and really happy to be talking about kind of, how we envision the future of open source silicon looking. Be a 30-minute talk, leave 15 minutes for questions. And then we will just get into it. So to open, what is open source? It's not a technical thing. It's more of a development model where technical collateral and designs are transparently shared under clear enforceable licenses. There are a lot of different axes on which different open source projects exist. I think the kind of key thing, or one of the key things, is it's not a free-for-all. IP rights, developer responsibilities, those are all clearly defined and well-run projects under a specific set of open source licenses, different governance models. Success in open source takes a lot of different forms. It can be everything from transparent, high quality code bases like a Linux or a Yocto, or even something like RISC-V, which is a transparent specification broadly available for industry-wide adoption, or even focused and broadly useful libraries like OpenSSL or Boring SSL. I think one of the key things about open source is that it is not one size fits all. There are many different models, participation standards, ways of consumption and productization. So often people are, familiar with one or kind of a limited set of open source models, but there's really quite a large variety, although the set of models that are adopted most broadly or kind of lead to the largest ecosystems are a bit more circumscribed than the full gamut of options. There are some key components of open source that tend to be broadly uh, shared. This is almost like a set of definitions. So typically there is some kind of technical collateral, often code, that is stored in an upstream repository, which is often different from where development and consumption, or you can call that productization, happen, which occurs downstream. The terms of use and terms of contribution to a project are typically governed by a license, either a permissive license or a so-called copyleft license. Now, on the permissive side, we're typically talking Apache, MIT, BSD licenses. On the viral or the copyleft side, typically GPL. In addition to that, there are often contributor terms, which is just good practice. Now, that's typically a contributor's license agreement or I always forget what this means, but I think developer certification of origin, DCO. They do sort of slightly different things, different levels of assurance. They can be used in combination or singly, but healthy, long-term sustainable projects typically have both of these features. And then there's often a set of common roles in different open source projects. It's very normal that anyone can suggest code changes as a contributor, but then actual upstream changes are reviewed and approved by qualified maintainers. What qualified means and how those maintainers are selected is typically done through an appointment determined by sometimes BDFL, Benevolent Dictator for Life model, more often a technical oversight committee that's responsible for the sort of that portion of the project. And then overall effort is typically funded by an administrative governing body. Again, lots of variations within this kind of set of parameters. But it's worth kind of considering each of these different components as key portions of an open source effort. There are a lot of different reasons, a lot of different ways people come to contribute to open source. Some of them are as simple as it's interesting, or someone wants to solve a hard problem. So degree of technical excellence, reputation is a large reason. Often companies will want to demonstrate that they have viable skill sets, commercially relevant skill sets in a particular domain. A good way to demonstrate that is by showing it. I think with some prior open source efforts, we've seen people use them as demonstrators for tool chains, toolkits in the silicon space, which has often provided a lot of value. So showcasing expertise. Sometimes people do it out of sort of processual desire to meet an ecosystem's needs. I would say a boring SSL or an open SSL are pretty good examples of this. So pooling resources or sort of focusing effort into a single implementation to solve very hard problems. But most of the time, it's really a combination of the above. And almost universally, these contributions align with commercial goals long term. So a lot of different factors, but often a commercial overlay that provides the financial support necessary to sustain a long-term effort. So companies often get involved because it can speed the pace of innovation. They can align on commodity implementations, no need to reinvent the wheel. The maintenance burden can be shared long term for common goods. Sort of it's easier to amortize that burden over the long term as opposed to taking it on solely yourself. And in the security domain in particular, Kirchhoff's principle looms pretty large. This notion that the only thing that should be secret about a crypto system is the secret material itself. So that's often enough motivation for people working in the security and cryptography space to work on open source implementations. What's the grounded business logic behind open source? Because it's all well and good to describe this in the abstract, but end of the day, someone is looking at a spreadsheet. So what's the business logic behind doing things open source? Well, it is a massive source of leverage for companies and organizations. So this notion that no one of us is as smart as all of us together does hold true. These individual contributions to shared efforts rather than happening in isolated silos really accrue and build fantastic value for the participating organizations. This has actually been studied reasonably extensively, especially in the software space. So Frank Nagel and his collaborators' work has shown that um, there's something like $9 trillion in value, and 3.5 times more would have to be spent on software today if we did not have open source as a sort of development ethos that we could build more valuable ecosystems on top of. Good example of this is the Linux kernel providing a really stable foundation for enabling downstream commercial development like Android and the vast majority of the modern cloud computing ecosystem. Um, and kind of to put a pretty clear point on it, something like 9 billion a year in VC funds goes into commercial open source development. And those entities that leverage open source as a kind of a core strength have much higher exit value. So the folks in the VC community would not be plowing money into this if they did not have some reasonable expectation and historical track record of getting pretty solid returns out of it. So it is a very pro-social value creating style of development when organized correctly and following in best practices. So not to overly belabor the point, but open source implementations do a very good job of setting standards, enabling efficient collaboration around the standardization of commodity technology to reduce costs in the long term. So very highly recommended work, really does a lot to show the commercial utility and value of all the various open source ecosystems that are out there. So what makes it so valuable? Kind of three primary drivers of that. These ecosystems are more valuable than the individual sum of their component parts. You're not spending time on non-differentiating features. You are spending time developing a truly unique value add, and overall development effort is you're sort of amortizing those maintenance costs. Um, so there's a whole set of smaller values that are sort of brought along by open source development. Um, you get a community from which there's a lot of talent that grows in. You also get brand trust and transparency, so it tends to have a very positive brand impact. And I think one of the more minor from a sort of a strict cost perspective, but potentially non-linearly valuable aspects is it creates a pretty solid platform for innovation. It is lower cost and lower risk to try new things out because you are building on top of the efforts of a very typically large ecosystem of participants, which is really quite valuable. Now, all of this is certainly true for software, but today more and more we're seeing open silicon implementations come into existence, and there's no reason to believe that these same fundamental forces are going to create any less value there. We're just earlier in the kind of earlier in the stage of ecosystem growth. I think so that's great. Open source is quite valuable. It's been shown to provide a lot of commercial utility, but a lot of that comes from kind of a disproportionate amount of that comes from sustainable open source projects. So these are efforts that are able to stand on their own, that provide enough incentive for both technical participants to participate, but also commercial entities to continue to fund them in an ongoing and shared and equitable manner. So typically, managed ecosystems, which are the most long-term successful style of open source project, explicitly agree on three different items. One is the governance model, which is typically two parts. An administrative component, which handles collection and disbursement of funds from the various participants, as well as a separate technical organization that's more focused on making the right technical decisions for the overall health of the project. Obviously, those two governance components tend to interact quite a bit, but they do have separate domains of concern. So that's a really good recipe for success in terms of licensing, contributor rights, setting an engineering roadmap, creating sort of a coherent, consistent ecosystem and set of contribution guidelines. The next is commercial utility. Open source isn't free. CI, continuous integration infrastructure, costs money is one example. And in order to maintain that open source flywheel, it's very important that there be a commercial value to the work that is being developed. But typically, you look for non-differentiating commercial value, stuff that everyone has to do or that everyone has an interest in, but that is not by itself overly unique or value add. And then, of course, the third thing, this seems a little bit obvious to say, but you have to produce something. There has to be a set of technical collateral, uh, ideally with a set of clear goals and objectives. There is a lot of utility in sort of providing a framework that people can execute against, tends to lead to much better outcomes. So a lot of variations in where different groups choose to land in terms of answering each of these questions, but having explicit answers for each of these questions or sort of a view of how it best suits your community to execute on these things tends to lead to better outcomes over the long term. Um, like I said, there's kind of a number of different styles of building an ecosystem. One of the most common ones is actually the kind of throwing it over the wall model, where a single party or a single organization will have something that isn't particularly relevant for them. They're not interested in maintaining. It kind of gets kicked over the wall. It often doesn't have support. This is rarely sustainable. That's not to say it's not useful. A lot of times these efforts they can often become abandonware, but they can also often be picked up and used in future efforts and build towards larger things. So a lot of this kind of category of open ecosystem is things that are just kind of better being out in the open than sort of withering on the vine behind closed doors. The second relatively common model is there's a single large supporter or sustainer. Um, that can be useful. You can get a lot done by doing that. Though those models do have some difficulty with long-term sustainability because focus shifts, priorities shift. You know, what's cool and interesting one day can become not something that a larger organization is interested in supporting in the long term. And it also tends to vest a lot of control and authority in a single entity, and interests might not always align. So the sort of largest or sort of most stable long term is a broad based ecosystem typically run by a committee. There are benevolent dictator models where this has been successful. I would say of all the models I would point to as really finding rather inspiring in terms of how they've done a really good job of growing an ecosystem and managing community and managing commercial interest is the Yocto Linux distribution. Ubuntu is another very good one with a slightly different model. And in these models, they do focus a lot on balance. They do focus a lot on stability. They can move a little bit slower, make decisions a little bit slower as a result, but there's enough buy-in from enough parties that they are well supported in the long term and tend to really be good, high growth, high utility ecosystems for all participants. It doesn't, all these models are different. They all have different applications and utility. One thing that's always worth considering when trying to structure an effort like this is you want to be able to accommodate lots of different types of contributor, everything from the drive-by bug fix to the person who is doing this as a full-time employee participating in the leadership of a project. Really, basically, this is a primary focus of theirs, and it's something that they're mostly paid to do. So before we get into the meat of how this applies to open silicon, I think it's worth covering some of the common misconceptions about open source. I think, and I've touched on a few of these already, but this concept that it's free is not in fact true. It is costly. It takes cost to contribute. It takes time to understand. It takes time to integrate. It takes time to support. It takes resources to support. So it's not free, but it is very efficient. So it is very cost efficient. It is a very high value for the cost that you put in, presuming the rest of the sort of structure is working in a happy way. Um, there's a notion that sometimes open source is volatile because anyone can change it. Like I kind of covered with the roles, that's typically not true in well-run open source projects. There is some set of checks and balances to make sure that contributions are being reviewed and monitored by qualified individuals, and that those individuals who have that committer authority are they themselves sort of overseen by a technical oversight organization of some shape or another. Another common one is that open source is buggy. So that's, there are bugs in all code. I would argue strongly that open source is no more buggy than proprietary implementations. And I can say from experience, I've had a number of employees who have, as they've gone down the open source path, realized that there's nowhere to really hide your sins. And so it has really motivated them to put a lot more care and attention into what they're exposing into the sort of external, in sort of an externally visible fashion. Um, I'm not going to make the argument, the many eyes argument, this notion that with many eyes, all bugs are shallow, because there are a lot of caveats around that have to do with engagement and sort of the specifics of the domain. So I think that can be true, but I don't think that that is an inherent property of open source. That's more a matter of structure and how you set up processes and contributions. I think another interesting thing that I've seen over the decade or so I've been working in this domain is a kind of common misconception that you have to work from tip of tree, which basically means working from the absolute like bleeding edge last commit of any given repository. That is uh, absolutely not the case, and just a real recipe for pain. It is almost always better to work from well-structured releases or a release process. And it is a bit of a red flag when you see projects that don't have a well-structured and thought-through release process. It doesn't have to be often. Yearly or twice a year is actually pretty common. But there should be a process, and that's kind of the stable sort of ecosystem checkpoint that most folks want to be working from. So the final one is that it's somehow not viable for hardware, that somehow open source does not apply the same as for hardware as it does for software. I think that that concern is of relevance enough and important enough that it deserves a slide all of its own to handle that point with the consideration and nuance it deserves. So can open source work for hardware the same as for software? Uh, yeah, absolutely. There's very little difference between the two, it turns out. My experience has been that anyone who believes differently is typically about to ask you for a rather oversized check. Um, there are examples today where hardware projects are running using an agile methodology with cloud infrastructure, standard blocks, commercially relevant open source implementations. So what a lot of this comes back down to is all those different characteristics we talked about with respect to what an open source project is. None of those are technical in nature, and open source is not a technical solution. So it works just the same for hardware as it does for software. It's primarily an organizational and a methodology, a review process. Now, will I say that that review process is going to be familiar or common to a lot of hardware development? Absolutely not. But that is definitely something that in my experience and that we have shown can certainly be made to happen with a supportive kind of ecosystem and knowledgeable participants. So open source is, you can kind of look at this as sure the software folks figured it out first, but then the executives at the companies and the product managers who are leveraging this stuff figured out how to both use open source to save and to make money. So it's been so successful, not in spite of not having any commercial value, but because it does have such immense commercial value, because you can build such valuable ecosystems on top of it, which I'm sure is a very kind of familiar trend or familiar sort of ethos for global platform, given the set of standards that it controls. So open source happens when something already is a commodity. It does not turn things into a commodity. So it works just as well for hardware as it does for software. How you go about doing that, slightly different. Um, so there are two fundamental costs to engineering always, development and maintenance. Open source impacts each of those differently. When an open source implementation is good enough, not necessarily complete, not necessarily perfect, just sufficiently good, it becomes cheaper to do downstream development to add your proprietary value add on top of it than it does to stand up an entire stack on your own. So that's kind of how it saves money on development costs. And that's often how a lot of people are sort of passively introduced to open source, extending it for something internal to their organization. Then the next way it impacts cost is on maintenance. So often downstream features are either not as valuable as they first appear or become less valuable over time, and then the maintenance cost of maintaining a downstream fork sort of rises over time, and at some point it becomes more valuable to just upstream that feature. There's a lot of other reasons why things get upstreamed, but this is a pretty common pathway. And so what you effectively end up doing is you are, because it's useful enough for enough people and not uniquely valuable enough for the original contributing organization, those features become upstreamed and the long-term maintenance cost gets amortized across all the participants in the project. So it can be very cost effective in reducing long-term maintenance costs because all headcount is expensive, everything requires upkeep. Anywhere you can save costs is valuable. Another place where this is somewhat uniquely valuable for hardware, and kind of ironically so, because this statement of collaborate on the core, compete on the edges is pretty universal in terms of open source business models. It just happens that in this case, we mean literal hardware cores. There's a lot of non-differentiating IP, spy device, I2C, peripheral, lots of stuff, right? Some common cryptographic accelerators. And instead of sort of competing on those small individual bits, it's much more valuable to compete on entire systems. End of the day, open source IP, closed source IP, someone still has to sell silicon, someone still has to sell an operating system. There's a lot of other components there than just the actual design of the devices of the individual blocks. And the assembly is never trivial, I will say that. So the other kind of point here specific to open silicon for security is that security is not really a differentiator. You will be, punished if you don't have it, but it's often a foundation for exceptional value creation. So when you look at the internet, one of the primary things we love to do on the internet is buy and sell things, and that has fueled many a fortune. And a lot of that rests atop these common open source cryptographic libraries like OpenSSL or Boring SSL. Um, the folks who wrote those, they didn't make their fortunes off of those. They often work for very successful organizations that made them off of other oblique things, whether it be ads or e-commerce or world's biggest online bookstore. So those kind of commonly applicable security frameworks often are the foundation, the trusted foundation for much more valuable ecosystems that lay atop them. So what makes a healthy, vital open source ecosystem? It's all about engagement. this having an engaged ecosystem is kind of the lever that allows you to create the most value and extract the most value from an open source effort. There's large incentives to be pro-social, to kind of work together in a healthy manner. You need developers to have confidence that the effort they put in is going to lead to value that they or their employers can derive from their effort or from what they put in. Typically, some kind of multiplier applied to that. You also need technical transparency. It's very important that there not be paywalls either in roles or in contributors. Now, that does not mean that anyone, that does not mean that the allocation of funds should not be controlled by the people who are contributing funds directly, but it does mean that there should be no barrier for, say, someone from an academic institution to contribute to an open source project just because they're not necessarily a paying member. Very valuable contributions, very valuable contributors. We have made really significant forward progress in post-quantum cryptography in particular as a result of some of those collaborations. And then also open governance, right? So some of Frank Nagel's other work has got to do with this problem of holdup, particular to having one overweighted party. Holdup is a particular economic term, or a term from economics, that has to do with the concern and adoption when you can't really predict what the future of an ecosystem is going to look like, because it's too easily steered by one member through, one reason or another. So that tends to be self-limiting on ecosystem growth. I think another important part of this fair governance issue is having the technical folks have a say in the direction it's headed, because no one likes doing free labor or feeling taken advantage of. And so that's one of the big reasons you end up with these split governance structures where the technical direction is set by the technical individuals with obviously input from the people who are providing the funding, but then the funding is controlled by the funders. So that's a very, very common, healthy, normal split. And then finally, engineering execution. Open source is not valuable if it produces nothing and it's just a set of high-minded ideals. So these vibrant communities are really essential. They are the sort of management interface for taking complex technologies and large maintenance tasks and turning them into something that provides commercial utility and is interesting enough to keep people engaged for the long term. So, I'd often say, well, we're at the cusp of open source hardware, but the reality is open source hardware is here today. RISC-V has demonstrated this very, very solidly. There's a large commercial appetite for these standardized extensible IP blocks. Umdia is predicting a 50% CAGR, which is, ridiculous in terms of RISC-V processor growth and adoption, estimating an overall, that they will take on a quarter of the entire market in the next 5 years, which is pretty exceptional. Some of the other reasons that are driving the adoption of open source silicon today, there's been a proliferation of standards. I think the Cyber Resiliency Act in Europe has done a large and a pretty good job of sort of reorienting people's focus on the need to really bake bake the security into the silicon and manage that throughout its entire life cycle. But chasing all these diverse certifications can become very costly and very complex if you're not starting from a common baseline. It is not the easiest thing to manage and navigate on the typical timelines in which you want to ship silicon. And proof of concepts exist today, right? Open silicon IP has reached commercial maturity. It has made it into commercial products. It is being broadly adopted in certain spaces. You just look at something like the OpenTitan kernel and associated projects, and that's a pretty solid proof point. So we're at this point where it does feel as though there's an opportunity to really do some effort in aligning with standards bodies and moving things forward as a entire ecosystem. So this is kind of an outgrowth of something I tell my team a lot of: share early, share often, as a way to motivate better, more open communication. I think it really applies here as well. To really benefit from open source, there's oddly enough, there's actually results showing that firms that participate in open source development that contribute upstream benefit twice as much as firms that don't over the long term. And that has to do with learning by doing, right? When you get familiar with the ins and outs, the full complexity of an open source project or a larger sphere than just the specific thing that you're trying to take advantage of, you often find a lot more value buried in there. And so as a result, you see this kind of positive feedback loop where firms that participate actively get more value out, they participate more, and everybody ends up benefiting. Um, so and again, there's this point of when things get good enough, not perfect, but again, good enough, it's often cheaper to leverage an existing open solution than it is to go and build something completely proprietary and from scratch. And there's a lot of value in getting in early because you can help shape frameworks, you can shape ecosystems, you can shape goals and objectives, and you're not in a position where you have to kind of, run after the bus after it's left its stop. So this has been shown pretty solidly with those that jumped in early on open source cloud and mobile ecosystem revolutions. And we see no reason for that to be any different for open source hardware. So this is all great. I've talked up the power and the promise of open source silicon, particularly when it comes to security. But what are we going to do about it? What is this really about? So how do we unlock the value that is present in secure open silicon? So the goal here is to balance or meet commercial and community goals and support a broad set of use cases and a broad ecosystem. Three primary sort of vectors, I guess, to succeed on to do that. One is open source, permissively licensed open source IP, preferentially stuff that's been silicon proven, kind of building on past successes. Versatility. Versatility is very, very important. Every design, every integration is different. It is very important to be flexible. And then finally, certification alignment. Not everyone is going to care about certification, but it is to encourage broad commercial adoption. And I think really to meet the goals of the Global Platform Organization, it is very important to align open hardware with certification compatibility. Doesn't mean, like I said, doesn't mean everything has to be certifiable or be certified, but things should not preclude certification because that does matter in certain organizations. And I will say that again, I come back to Yocto as a really good example of an open source distribution. So what we're really talking about here is building a framework to create a secure open silicon distribution. This is something that is uh, modular, that is high quality and can support diverse markets, certification, use cases, and security levels. So again, not one size fits all, but something that can really serve as a framework to assemble different modules, different subsystems that have different applicability to different use cases, different markets, and support the broadest kind of set of ecosystem partners. So with the support of Global Platform, the a board of directors about 2 weeks ago, this Trusted Open Source Silicon Task Force was created. Very happy to have their support in creating this. Three primary goals: basically follow best practices for open source principles, I guess I would say, for this distribution. Support a broad ecosystem of participants, and really help drive and support the adoption of global platform standards. So in the first goal, we're really talking about administrative and technical governance charters, establishing a transparent legal framework for open source development, building a clear release process, well-defined and documented project scope. The second one, that balance of community and commercial needs to really bring on all participants. I've spoken to quite a few people who are very excited to participate, some on the commercial side, some on the academic side, some who are just individuals who have the skills, but have either been successful enough that they don't need the financial support, or people are just very interested in this and they want to do it in their spare time. So there's a lot of pent-up demand out there, I think, for this kind of a distribution. And I think that's what really comes down to ecosystem, and sort of the community support is a very big part of this. And then finally, potentially most important, is helping support and drive adoption of global platform standards. Global platform covers such a broad and relevant set of standards at this point that it is an ideal home for this kind of an effort. It's very important to align different configurations with all of the different, whether it be protection profiles or whatever the kind of certification framework that's required is, and helping to encourage that adoption by keeping implementation quality high, but also outreach and sort of participating in other relevant standards bodies, whether they be JHAS or NIST or something regional or even international. So those kind of channels, those communications are very, very important to keep an effort relevant, to keep an effort a distribution like this really strict and on track. So I'm going to close with a call for participation. So I am chairing this effort, representing the kind of overall task force. I'm pleased to be kind of supported by Barney Ibrahim at Revos and Ilya Stolov at Winbond. All Global Platform members are eligible to participate in this group. People who are not members, I would encourage to consider membership to participate. There's some links attached where you can learn more about the task force. And yeah, I'm happy to answer any questions either offline, or I believe we've got probably about 15 minutes. Hopefully I didn't run too far over, but we're very, very excited about this effort. We're moving quickly with it. Really looking forward to more participation, and we will probably sometime in the next week or so send out the next set of meeting invites and get on a regular cadence to drive this forward. All
So
right,
there are a
and
couple
that's
questions that
sure.
came in, Dom. First was diving deeper
Oh,
than the
sorry, I
generic
can't.
value.
Give me one second.
I'll
I'm
read.
sorry. It's in the chat.
Uh, yeah, I'll read you the question, and then maybe you can
Oh,
address it.
sure.
Yeah,
So the
it's on
first
the
one,
chat.
yeah. So the first one is diving deeper than the generic value of open source. What are some of the challenges that global platform may need to overcome to apply the principles of open source to silicon?
Sure. So this is from Bill Mazzara. So thanks for that. I guess first a statement about scope. So the task force is set up to really sort of, I'd say, enumerate a lot of those challenges and come up with a kind of initial set of answers for how we structure this kind of effort. The challenges over the long term, they're always the same. It's building that community, building that ecosystem, and if you are unfamiliar with open source, it's education can be a big part of this, right? It can take some time to see the value, and if you're used to building chips, you say, well, but we're good at building chips. Why would we want to do any of that in public? But then, you start looking at it, and you're like, well, we've been carrying around this wonky 32-bit RISC, or not RISC-V, wonky 32-bit homegrown core with a homegrown ISA for years and years and years. It would be better just to use like a 32-bit RISC-V core, right, with the right integer and compressed instructions or whatever. So over time, there's really no way to solve that other than time and education and sort of patient engagement. So that's always just a persistent challenge. I honestly don't believe there are any significant technical challenges because, again, open source is not a technology. It's a way of developing technologies. It's a way of communicating and collaborating with other participants, right? Some of whom may be collaborators, some of whom may be competitors. So you kind of have to learn to figure out where you can work together, and where your unique value add is, and what you're building on top of the open source platform. Hopefully, Bill, that answers the question sufficiently.
So another question came in from Jeremy. We have seen some open source hardware projects which follow software best practices rather than best practices in hardware design, which makes reuse harder than it could be. Any comments on how to avoid this?
Yeah, so this is actually a really common one, right? And I think where I see this tend to go sideways the quickest and most often is the way software thinks about test and the way hardware thinks about test or design verification are often radically different. Again, a lot of this comes down to communication. So one of the right ways, one of the ways I've seen be most successful in sort of increasing reuse is actually being, I would say, I'm going to be polite to myself and say being a stickler about documentation and interfaces and very clearly communicating sort of how versions need to change when interfaces change and being very proactive and communicating to all maintainers and contributors to some extent what the requirements are to make these changes. You are absolutely right. I've seen a number of projects that tend to wither on the vine because they have not put sufficient thought into um, basically interfaces at the hardware level. Part of the way, part of the way I've tackled that in my company is the company is it's got a number of experienced hardware people and a number of and quite a few software folks, and there is a very tight loop between them, right? So yeah, that is absolutely a challenge, and it's one that I didn't want to get too far into the weeds, but that's definitely one that is very important to explicitly talk about from the very beginning.
So another question that came in from the Q&A section from Deepan. Open systems thrive on iteration and agility, but certifications usually freeze designs for stability. How do you reconcile these tension, ensuring open silicon can evolve quickly while still meeting the stability and rigor demanded by certification bodies?
Oh, I'm sorry. So is there any chance could you do so I can I answer Chris's question, which is in the chat and I can see it? Because that was a fairly complex question. Do you mind pasting that into the chat? I'm not seeing it anywhere. And it's a little hard to
Okay.
follow if they're not in the chat.
So I pasted
Okay,
the
I
one
see.
from.
I see. Uh, so they do thrive on iteration and agility, but again, remember the point I made about it's nuts to work from tip of tree. No one does it like you should never do a tape out from tip of tree. People should be working by and large from stable releases, or if they're not working from tip of tree, or sorry, if they choose to do that, they should be well aware of the risk that they are taking, right? So stability, reproducibility, these are very, very important. What actually happens in practice is at some point you should be working off of a release. If you're not working off a release, okay, you're probably going to work off of a fork at some point. Fine, kind of your responsibility, right? Not best practice, not recommended. So yeah, you should really honestly mostly be working off fairly stable frozen designs. So this is where sort of the upstream development flow, which is in fact fairly it's crystallizing at the edge, right? It's always moving forward. It's always effectively unstable. That is not what one should be building their hardware off of. That should be being taken off of stable release branches. Now, getting those release branches aligned with the certification bodies, the required rigor, because it is very challenging. That is going to end up being a collaboration probably between us and this task force, as well as a lot of the other folks who lead these efforts in global platform. But also, I think realistically, with the certification bodies themselves, with folks like NIST, things like that. So. No, these are great questions because these are not like none of these have easy trite answers.
So I think
I
we
would
can
say
tackle
so.
a couple more.
Yeah,
Yeah, a
just
couple
to
more.
follow up, just to get to
That's
Deepan's
done.
the other part of his question real quick. So when I say common baseline, I want to be clear. I'm not saying one size, one design that fits all. It's almost better to say a common baseline of components, of subcomponents, right? So the reality is I've never seen my experience with root of trust development, secure silicon development, and the OSs that layer on top of it, and the cryptography that layers on top of it is frankly, it's a Venn diagram, but instead of 3 circles, there's about 15. And everyone has things that kind of look similar if you squint, but there's always enough variation that you're never going to get one design to rule them all. But that doesn't mean you can't, have a bunch of Lego blocks, right? That are in some, possibly even pre-certified in some instances, although that can be very challenging. But the point is that, you don't have to keep reinventing the KMac or the AES engine or whatever it is, right? You can start from a common baseline and sort of layer value on top of that. Hopefully that answers that question. And the rigid and
And I think
political, yeah, I mean,
we
standard answer is
the
global platform.
so I think we can
Sorry.
answer one final question, Dom, from Chris. One of the challenges is maintainability. So the system has long-term basis. How best to ensure the complexity of systems are managed well? Appropriate modularity is adapted for the current system size. This isn't a CI thing. It is solely through the ministrations of the moderators and those with approval rights.
So I would push back a little and say it certainly is not solely a CI thing, a continuous integration thing. However, good continuous integration can actually make this problem a lot more tractable. So it is, bless you. So it is a combination of CI, maintainers, effective engagement. So there's kind of two sort of halves to the solution here. One part is the technical stuff, the CI, the standards, the style guides, things like that. The other half is the processes, right? Do we all have a good sense of what a major change is, and is that being appropriately discussed at the appropriate level in the governance structure? Typically, there's kind of a layering here where anyone can suggest a change, maintainers who are typically qualified for their individual kind of area of expertise are trusted to handle or kind of be the first line of evaluation for whatever their particular domain is. Say it's asymmetric crypto or something like that. But then those decisions, or those, if there are issues, those can be kind of bubbled up to a technical steering committee level. And I think one of the important things is it's very common for there to be a sort of being a maintainer is less, it's not a privilege. It's sort of a sacrifice that some people are generous enough to make for the overall good of a community, to keep a healthy code base, to keep complexity under control. And so, you really are behooven to go out of your way to keep those folks happy as contributors. So, and that's more on the process and the kind of governance and management side. So.
And I think
These
that's
are
the
all
final
very
question.
good questions.
Yes. So I think in the interest of time, and I think this is the end of the session. Thank you, Dom, for your very insightful presentation and for sharing your expertise with us today. And it was a very good discussion with all the questions that came in. And thank you everyone who joined this Tech Talk session for today. We hope you find the discussion very valuable. And as a reminder for everyone, if you have any topic in mind and can suggest a speaker for future Tech Talk sessions, please don't hesitate to reach out to secretariat@globalplatform.org. And we look forward to seeing everyone for our next Tech Talk session. And until then, take care and goodbye. Thank you, everyone. Thank you so much, Dom, once again. It was a
Thank
very
you all
good
so
session.
much. Appreciate it. All
Thank you,
right.
Thank you,
everyone.
Dom. Thank you, Mac. Thanks, everyone. Bye-bye.